This is Hickman, and in this video we're going to be going over linearization. Linearization was on the 2014 AP Calculus AP exam. Newton's method is not on the AP exam, but it is on the BC. We will not be going over that today. So the basis of linearization, so if a point P is a point of differentiability for F, then by zooming in close enough, the curved segment containing P will look like a line, which is going to be the tangent line at P. So if you had this graph and you kept zooming in and zooming in and zooming in, it would eventually look like a line. Okay? So next, f of x is going to be locally linear at P. So again, here would be a snapshot on your window. So here's point P. You would see something like this. It would look like a straight line. And that would be when it is locally linear. So linearization, so if f is differentiable at a, which means it has a limit and the point is defined at this value, then the equation of the tangent line is going to be L of x equals f of a plus f prime of a times x minus a. And it's going to define the linearization of f at a. So L of x is going to be approximately f of x, which is the tangent line. So let's find the linearization of f of x. So here's example 1. You're looking for the linearization of f of x equals 1 over x at x equals 2. Okay, and remember that 2 is x equals a from the definition right here. Okay, so a equals 2. Okay, so here's our definition of linearization, which is L of x equals f of a plus f prime of a times x minus a. Kind of looks a little bit like point slope form. Okay, which it is. So this is m times x minus x1 plus y1. Okay. Alrighty, so we need to find the derivative. We got f of x. Well, f of a is going to be, of course, so let's do f of a first. So f of a, which is going to be f of 2, is 1/2. Now we're going to do f prime of a, but first we got to do f prime of x. So that's x to the negative 1, which is going to be negative x to the negative 2, which is negative 1 over x squared, which f prime of 2 is going to be negative 1 over 2 squared, which is 4. Okay, so L of x, following the formula, so is f of a, which is 1/2, plus f prime of a, which is negative 1/4, times x minus a, which is 2. So you have 1/2 minus 1/4 x plus 2 over 4, which is 1/2. So you have negative 1/4 x plus 1. Okay. So that is the linearization of f of x equals 1 over x at x equals 2. Next, we're going to be learning how to approximate a root. So f of x equals the square root of 1 plus x at x equals 0. And we're going to use it to approximate so this is just another application of linearization. The square root of 1.02 without a calculator. Sounds scary, right? Well, you got brains. You can work this out. Okay? So, here we go. So first, let's do f of x. So f of x, so f of x equals, and so x of a, so a is going to be 0. And so f of x equals the square root of 1 plus 0, which is the square root of 1, which is 1. Okay, now you're going to find the derivative, which is f of a. A little bit more specific. So then we got f of x is 1 plus x to the 1/2, and that derivative is going to be 1/2 1 plus x to the negative 1/2, which is 1 over 2 square root of 1 plus x. So now you're going to do f of 0, f prime of 0, because you're doing f prime of a, and that's going to be 1 over 2 times 1, which is 1/2. So the local linearization, L of x, is going to be f of a, which is going to be 1, plus f prime of a, which is 1/2, times x minus a. So you get 1 plus 1/2 x, or if you like it in point slope form, you could do 1/2 x plus 1. So you're thinking, so how does this help me with this? Well, here we go. So to approximate, so first let's look at something. Okay, so so we have the square root of 1.02. And that is also can be said to be 1 plus 0.02. When you're approximating the root of 1.02, you're going to do L of 0.2 equals 1/2 0.02 plus 1 equals 1.01. And that is how you determine what it is going to be. Okay, so you're mostly only worried about this part. Okay, next example is going to be approximating roots. So approximating roots. Let f of x equal the basic function, the square root of x cubed, or the cube root of x, etc. of the given. So you're going to take the derivative of the basic function, seek the nearest perfect square, perfect cube, etc., and use it for a. X is going to be used for the original function. So we have an example of the square root of 123. So a is going to be the nearest perfect square. So a is going to be 121, and x is going to be 123. Okay. All right, so f of x, so now we're doing linearization. F of x is x, and square root of x to the 1/2. And remember, a is that, so you're going to be doing f of a is going to be 11. Square root of 121 is 11. And then you're going to be doing f prime of x, which is going to be 1 over 2 square root of x. And f of 121, f prime of 121, is going to be 1 over 22. Okay? So here is going to be the linearization. L of x is f of a, which is going to be 11, plus f prime of a, which is 1 over 22, times x minus a. Now remember up here, x is 123, so you got 123 minus 121, which is going to give me 11 plus 2 over 22, which turns out to be approximately 11.09. Okay, well let's see if that is close. Let's use our calculator to confirm what it is. Okay, so we're going to have the square root of 120 is 11.09. I like that one better than the other one. Well, let's look at what 11 plus 2 over 22 looks like. Okay. And then you got the square root of 123. Okay, pretty close. Okay, that's it for linearization. See Renweb for your homework.